Hello, how are you, everyone? How are you, everyone? I hope you are all doing fine. I hope you are all doing fine. Okay, welcome to Supreme Institute of Applied Sciences and Technology. Welcome to Supreme Institute of Applied Sciences and Technology. Okay, this is uh, this is networking configuration, and by the way, you're still with Dr. Piri, and on today's lesson I'm going to take you in CCTV under the topic of network configuration, as well as application of a CCTV. So we'll look at network configuration. How can you configure the cameras, and on the application of CCTV, where can they be used? Sure. Which places or premises can you install the CCTV? So not to waste much of the time, I think about this topic we discussed with you guys. I think some of you that attended the live class, you still remember about what we discussed under the configuration. Yes, so here it's just the summary of what we discussed last time. So maybe to remind each other, we define what a configuration is. We define the difference between configuration and installation. Yes, so installation, this is the time where you get the cameras, then you mount them to the location where you want them to be installed. For instance, maybe you have identified the location where you want to put the camera or to mount the camera. So by getting the camera physically and mount it either to the pole or to the wall or anywhere else where you want the camera to be capturing the information, that is an installation. Then configuration is where now you give the IP addresses of each and every camera. Sometimes you can give maybe similar password or different password, but mostly is to put the IP cameras on the networking. Yeah, put the IP cameras on the networking. That is configuration in order to display on the monitor screen. Sure. So what are the steps when one wants to configure the cameras, or what are the requirements that someone must prepare before the steps of configuration? These are the things that someone should bear in mind. So number one, you must have the complete system of the CCTV in order to do the configuration. What do I mean when I say the complete system? You must have an NVR. Yeah, we're talking about the IP cameras, not for analog or HD. We are talking for IP cameras. That's where we are looking at on this topic. So you must have an NVR, then a switch, a monitor, a mouse, as well as the cameras, even the router, if at all you want your cameras to be monitored remotely control. Okay, when we say remote control, meaning you want to be controlling or monitoring your CCTV using the network or the phone or the laptop wirelessly. Okay, that is a wireless connection, and it will require a router for it to transmit the data. Okay, yes, so you must know the connection for the CCTV before you start the configuration. of the cameras. Okay, so here on this picture, wait a moment, let me do this. Okay, so on this picture we are seeing here where it is written analog camera. So this is the analog camera, then it's going to a network video server, then from there it passes to the Ethernet, then Ethernet is taking it to the backup switch, then a backup switch is taking it to the DVR. This is the DVR. Okay, then from there is displaying it to the monitor here. That's what is happening. Same here. So this is the network camera. So the network camera is taking the information to the using the Ethernet cable or Cat6, sometimes even a Cat5, but we are looking at a Cat6 at the moment, taking it to the CCTV CPE. Okay, then from there is taking it to the backbone switch again. Then from there the other cable is one cable that is taking to the MVR or the DVR. So let me clean the screen so that maybe I can explain a bit here. Excuse me, what is happening here. So first and foremost, you need to understand the diagram, what is trying to explain here. So not to focus more, but it's the similar connection. What they are trying to apply here is that then a connection before the configuration. First, you need to connect the cameras or all the cameras to the switch. Then from there the switch is going to transmit data to the MVR, then the MVR will display it to the monitor screen. So meaning this connection, you must have the cameras, which you have the Cat6 cable or Ethernet cable, which will connect to the switch, then another for power. Mind you, the cameras, they need power for them to go on, unless you're using the PoE cameras. I think by now you know the difference between a PoE and an IP cameras. They are both IP cameras, but the difference is that the other one is an IP as well as a PoE camera. So a PoE camera is the camera that has a power over Ethernet, meaning using the same Cat6 cable, it can transmit data as well as supply power for the camera to go on. Then for an IP camera, it doesn't have the provision or the function of the PoE, meaning you still need the provision of a power supply by using a 12 volts or 9 volts charger. Yes, so in a simple connection of the CCTV, like I've said, you need to have a complete system of the cameras, switch, MVR, hard drive, a USB hard drive, and a mouse as well as a monitor. So meaning you get the cameras. If maybe for instance you have 4 cameras, all the cameras, you connect them to the switch, maybe directly, you know, this part, you connect every camera to this switch here. Then even this one will go direct to the switch. Then instead of having all the cameras connected direct to the MVR, you connect them to the switch, meaning some of the MVR or the DVR, more especially MVR, because the DVR, they have those ports for BNC, so it matches the number of the cameras. But for an IP cameras or network cameras, you find that the MVR only have one RAN port, or for RJ45 port. So we have 8 cameras, 16 or 32 how can you connect all of them to the MVR whilst it only have one RAN port? So meaning all the cameras, you need to connect them to the switch or backbone switch. Then only one LAN port is on that will go to the MVR here. This connection, MVR here, meaning you have reduced the process of buying an MVR that has maybe 8 channels or 8 ports for RJ45, as well as the standard of the CCTV installation. In order to avoid the system looking dirty or looking unprofessional, is the reason why most of these MVR, they only have one port for LAN cable. So meaning all the connection they done through the backbone switch. Then only one data cable is the one that goes to the MVR for the system to operate nicely. So that's the connection that is here. Let's proceed. Digital transmission. So here is just the connection where you have Sentinel transmitter, then encrypted digital video here from here. Okay, then we have Sentinel receiver, then you have a router, like I've said. This is a Cat6 cable that I've used here. So this is just the connection. This is the switch. So have you seen here from the explanation? Have you seen the cameras that are here? You have one camera, 2, 3, 4 cameras. All these 4 cameras are connected to the switch. Then from the switch is going to Sentinel transmitter. Then from Sentinel transmitter is taking it after encrypted to the Sentinel receiver. The Sentinel receiver to the router. So this is just a connection that is there, like I explained on the previous picture here, where I said instead of connecting all the cameras direct to the MVR here, instead you connect them to the switch. Then only one RAN cable is one that will go to the MVR, and will still have access to all the cameras. Okay, that's what is it. That is what is happening here, where you are seeing all the 4 cameras are connected to the switch. Then from the switch is taking it to the transmitter, then transmitter to the transmitter receiver, then router. So in a simple connection, not to be complicated, let me do this. Let me clean the screen. Okay, let me clean the screen. So here all these cameras have camera 1 here, camera 2, camera 3, camera 4. In a simple connection, they are all connected to this switch. Then from there, one can go direct. For instance, this is the MVR. Or if you want to have a remote control, instead of using this kind of a connection, we can forget it for now. Meaning this router, if you want to have a remote control, another cable will come through here to the switch. Okay, like this. Then here we have, maybe we have the here, that's where you have the MVR here, NVR here, meaning one port come and connect to the MVR. Have you seen the connection? All these 4 cameras that have connected to this switch. Again, this router that has the internet has connected to this switch. Only one port for RAN cable, Ethernet cable, is one that has gone to the MVR. Then here we have maybe that's where we have the monitor screen here. We have the monitor. So a VGA or HDMI cable will come and connect to this monitor. Then here we have maybe a provision of a mouse for operation. Yes, so this is the connection. All the cameras are connected to this switch. Then from the switch they're taking it to the MVR, then MVR to the monitor screen. Then this router is connected to this switch in order to have a remote control of the CCTV. But in a situation whereby you don't need them to go online, there is no need to have the router. I hope you have understood the connection that is here. Let's proceed. So CCTV, sorry, let me try to zoom a bit. CCTV image transmission system using DSL or optic cable. So okay, let me start explaining here the points. So the CCTV is the image transmission of CCTV camera applied DSL and the optic solution. So in short, before I even explaining anything here what they're trying to say is the maximum or minimum transmission speed of CCTV depending on the type of the cable that you can use. I want to make you understand in a quick way. So for instance, we have a max transmitted speed here. Max transmission speed, sorry, is about 1 Mbps or 5 kilometers. Then efficient transmission speed is about 3 Mbps here. Yeah, here 3 Mbps or within 4 kilometers. Okay, so using optic cable for long distance image transmission is 15 kilometers. Okay, that is using optic cable. Then using telephone line instead of coaxial cable, it makes maintenance easier. Okay, using telephone line instead of coaxial cable, it makes maintenance easier. Okay, then suit for security and surveillance system through closed network of DSL. So what are they trying to say here? Let me finish. 3U shelf and 9 rack mount type for maintenance easier. System could be composed to max 24 ports using DSL or optic units by user. Then in case of using optic system, image transmission by 2 Ethernet cables of CPE. I can't tell. Okay, which is connected with the camera, also designable. Okay, so here the main point is about the speed and the type of the cable that you can use. For instance, if you use the telephone line instead of coaxial cable, it makes the maintenance easier. Then again, like the maximum transmission speed is 1 Mbps or 5 kilometers. By the way, about this, I once explained on the previous topic that it depends on the distance. If you have a longer distance, for instance, maybe it's about let me say 50 feet, or not 50, it's too small, maybe 250 feet. Then if the distance is longer, it means even the cameras, the quality that is going to give, it will be a very low quality of video signal, meaning you still need to provide another switch in between in order to still maintain the standard quality. Or if not so, you can use the different cable. There are types of cables which you can use in order to maintain the good quality. Because if you have maybe let me say 200 meters or 250 meters, meaning for the signal to be very poor. The longer the distance, the poorer the quality. The shorter the distance, the higher the quality resolution. Yes. So excuse me. So when you notice that the distance is too long, so in order to maintain the good quality, you can provide a switch in between. It can be maybe 2 switches or 1 switch. Sometimes you can use the nano stations for wireless transmission in order to reduce the distance and maintain the good quality. Okay, so let's proceed. CCTV optic CPE model C800F2. So this is the capacity of 1 port standard interface, CCTV Ethernet line data connection. Okay, for now these they not much important at the moment. Then the size, the power. Okay, so this is the model of the CPE. They're just showing us. No need to focus more here. We can proceed. So we have technology development, waterproof CCTV. So this is the waterproof camera. As you can see when you look at the picture, this is the Brady camera, meaning it survives outside. It's a weatherproof camera. Okay, we have a dome and a Brady, but we have a lot of types of cameras, but for now we are looking on these both 2 cameras. So computer controlled analytics and identification. So today's here, that's where we are. Yeah, computer controlled analytics and identification. Okay, so today's high definition CCTV cameras have many computer controlled technologies that allow them to identify, track and categorize objects in their field of view. Maybe I use a mouse a bit. Okay, so today's high definition CCTV cameras have many computer controlled technologies that allow them to identify, track and categorize objects in their field of view. Okay, so what does this mean? Yeah, you know, on today's you find that they have a lot of technologies that allow them to identify or track and categorize objects in their field. So they have advanced their system that they can use in order to have the control of this system. For instance, you have emotion detection, you have face identification. All those things, they help in tracking and categorize objects. For instance, emotion detection detects the temperature of a human being, as well as a facial identification. Once you pass the camera, then the camera will identify your face. Yes, if there is a provision of AI, it's going to match your face. Maybe if it's not clear, then it's going to enhance a picture that looks exactly like maybe you or any other person that is relating to that picture. That's how you can identify maybe such kind of a person, whereby you don't know the person or it's not clear. Then the AI is going to enhance from that picture how that person looks like in real life. Okay, then also a face identification. It will be easy. Once you pass on the camera, then it's going to detect your face and bring the whole image, even you including all your details, where you're coming from, all your biography. In short, if you have a criminal record, everything will pop up on your biography depending on how they set the system. Okay, let's proceed. So here we have what we call video content analytic. So video content analytic is the capability of automatically analyzing video to detect and determine temporal events not based on a signal image. So let me change the case. I use the blue. Okay, not that one. Yes. As such, it can be seen as the automated equivalent of the biological visual context. A system identifies and compares objects in the database using size, speed, and sometimes color. The camera's actions can be programmed based on what it is seeing. For example, an alarm can be issued if an object has moved in a certain area, or if a painting is missing from a wall, and if someone has spray painted the lens. Okay, so these are the things how you can identify or say the camera can ring. For instance, if maybe an object has moved from an area, or if painted has been removed to the wall, or paint has been or someone has painted the wall, then an alarm will ring, meaning anything that is suspicious, depending on how they set the settings, then the alarm must alert the user. Okay, so VCA also has the ability to track people on a map by calculating their position from the images. It is then possible to link many cameras and track a person through an entire building or area. This can allow a person to be followed without having to analyze many hours of film. Currently, the cameras have difficulty identification individuals from video alone, but it connected to a key card system. Identities can be established and displayed as a target over their heads on the video. Yeah, so for cameras alone, it cannot be easy to identify the image of the person. It's need an advanced system and the softwares which can detect that face, then analyze it and bring a similar picture of that person. And even sometimes, depending on the system, how advanced the system is, you can even bring the biograph of that person, the maybe secondary level of education, primary level of education, tertiary, where that person works, for how long has been working, if there's any criminal record, all those information the system will bring once the person has been identified. That's the reason why sometimes when you watch the movies, more especially those for maybe FBI, when they're investigating for a criminal case, then you find that they have maybe the picture of that person, they capture that picture, then they take it on the system, on the software, then through that image they will match the faces of the images, or maybe faces of the criminals that they have on their list. Then you find that that picture, even if it was not clear, definitely to match one of the criminals on that list, and even bring the full biography of that criminal. Okay, so let's proceed here. So we have facial recognition. So facial recognition system is a computer application for automatically identifying or verifying a person from a digital image or a video frame from a video source. So facial recognition system is a computer application for automatically identifying or verifying a person from a digital image or a video frame from a video source. Okay, so this is the system where you have like I have explained, a facial recognition, whereby a computer with an application or a software will automatically identify or verifying the image of the person or the video frame from a video source. Okay, then one of the ways to do this is by comparing selected facial features from the image and a facial database. Yeah, so like I was explaining, when you have more especially for FBIs, those of you that like watching the investigation movies or series, sometimes maybe I can give an example. I'm a fan of series. Maybe let me talk about the Prison Break. The Prison Break, you know, the Michael Scofield, the guy that wanted to, some of you that watched Prison Break, the guy wanted to rescue his brother who was framed and was sentenced to life in prison and was supposed to be killed depending on the day where the case was supposed to be closed. Now you find that that person, if we were to use the facial recognition, or maybe let me put it in this way, they have a lot of maybe images of the criminals that were involved in the same case. So you find that they have maybe one image that is not clear, like this one here, this image. So they want to find the real owner of that image. Sometimes a video footage or a picture maybe can be captured from maybe a different place or near the scene. Then they want to match that face to the images that they have in the database to know what transpired, or if indeed the images that they have in their database is not connecting to the crime scene that maybe someone has been accused on. So based on that, they'll get that footage, or where they find that picture, or maybe the transaction that was being done, if it is connected to that case, then they'll get that picture and try to trace and track it in the system. Then they find out that yes, indeed that person is there in the list. Then based on the information and the biography of that person, maybe has a criminal record, or maybe has anything that deals with a murder case or stealing, then they will connect it according to the scene or the current situation. Sometimes if you watched maybe the Blacklist, more especially this series that they investigate cases, they have a database of different faces of criminals. So once they get your image, they cannot start comparing using our naked eyes or their naked eyes, but would rather use this system where they just get your image on this other side. For instance, here, let me do like this. Okay, for instance, this is the system whereby they have the names of the criminals here, images. Then they have found maybe one image here, so they put that one image here and scan it. Image, they'll scan it. Then after scanning this image, by the time it will be done scanning here, it must match to one of the images that they have in the database from this side. Then they'll definitely know the person from there. Then after scanning, if that person has been identified, then in this other side it must show the biography or the information of that person, where he did his secondary education, primary, if at all he went to the university, where he's working, for how long has been working there, what caused him to be in the prison in the first place. All those informations are very important during the investigation. Okay, so let's proceed. We can proceed. Let me clean the screen. Okay, so let's proceed guys. So the combination of CCTV and facial recognition has been tried as a form of mass surveillance, but has been ineffective because of the low discrimination power of facial recognition technology and the very high number of false positives generated. The type of system has been proposed to compare faces at airport and seaports with those of suspected terrorists or other undesirable entrance. Okay, so how do they match these faces? They get the faces from the airport, for more especially to the Western countries. What they do or usually do is they check the faces that they have in the database from the airport or in the seaport. Then they'll be able to trace or match the faces using the information they have from the airport and the seaport. Definitely it must match, because most of people in these Western countries, like America, US, like America, London, China, you find that their most mode of transport is airplane. So definitely they pass the airport, and there is face capturing, whereby they detect the face, they put it in the system before you enter in their country. Then the passport, every details of your information, they must have it at the airport. Even if you fake the passport, but they will catch up on you by faking that information, because then they have the original one. Or sometimes maybe you can use the fake face of another person and using his passport, but once they check in the system, sometimes if you are lucky you can pass without any problems, but when it comes to maybe the DNA or those kind of information which they are not going to match you, definitely soon or later they are going to catch you. Or during the investigation, maybe you commit a crime, then they'll start now doing the investigation. Then they find out that the person where you used an image, you killed that person, and that person is a normal someone who maybe died 3 months or a few months ago, but his image is still existing. Then they'll definitely say that there's someone who is using a ghost image. Then definitely by tracking in the system using the images that they have on the database from the airport or the seaport, they will find the person. Okay, so let's proceed. So here is where it says computerized monitoring of CCTV. Computerized monitoring of CCTV images is under development, so that a human CCTV operator does not have to endlessly look at all the screens, allowing an operator to observe many more CCTV cameras. This system do not observe people directly. Instead, they track their behavior by looking for particular types of body movement behavior, or particular type of clothing or baggage. So what are they trying to explain here? The thing is, instead of when you're on the CCTV, those that have been as a CCTV operator or they have been on the CCTV screen, you find that you have maybe the 2 cameras and it is a busy place. People are coming and going, in and out. It's a busy place. Maybe let me say from 6 hours up to 20 hours, those movements. Now, for someone who is monitoring maybe the 2 cameras, it won't be easy to identify the person that they're looking for based on the just common movement, but there are specifically movements that they are looking for, maybe suspicious movement, like in this case, allowing an operator to observe many more CCTV cameras. This system do not observe people directly. Instead, they track their behavior by looking for particular type of body. So for instance, body movement, you can tell to, okay, this is the person that you're looking for, and by doing so you observe how someone is doing things. It can be in the public, but even in the movement, you find that after seeing the police passing the town, then that person maybe changes the direction or maybe delayed himself a bit in order to buy time, or sometimes even by dressing itself, there is a mask on the face, or maybe the person put the face mask for someone's facial. Then from the system, it will be able to detect that this is not the original face of the person. Then from there, it will be easy to identify that, okay, this person is a criminal. For instance, in this picture, have you seen this? A white man, and have you seen what is happening here? So in case, in a situation whereby this person maybe uses the face of this man, definitely is going to match that maybe two people, they are using one face, because in terms of identification, it's not everything that can be exactly as that person. Okay, so let's proceed. What is CCTV? Where is CCTV located? So let me use this. Where is CCTV located? So the CCTV, they can be located on cities and towns, car parks, within and outside organizations, car parks, residential areas, within private homes. Okay, so for now, I think we are going to end here. This topic that we are starting is a simple topic and easy for understanding, but for now, I think we're going to end it here. Next time when we meet, you're going to look at where is CCTV located, or in short, where which places would require to install the CCTV systems. Okay, yes. So all right, guys, make sure you study and go through these notes. The exams are approaching, so we'll meet in the next lecture, where we'll be looking at the application of the CCTVs. For instance, we have application on toll gate surveillance system, then application on apartment surveillance system, then factory surveillance system, then we have airport or seaport surveillance system. So we are going to look at all these when we meet in the next class. Security surveillance or traffic control systems, army security area surveillance system, then we have school or safety system, that is kindergarten. Okay, so even for, I didn't see it for tomorrow's. Okay, so this is what we are going to look at in the next lecture. Bye.